Hello there. We're going to talk about carbohydrates, which is one of the food components. It's going to be very basic information. I'm sure you will have to learn more when you go into second year. But for a first year, it's going to be very basic. So the learning outcome is very simple, getting some kind of flavor about carbohydrate, CHO, and we talk about the most basic of carbohydrate. The CHO contains carbon, hydrogen, and oxygen. The basic building block of CHO is simple sugar. That is also termed as organic alcohol. So maybe you have heard before, this carbo exists as monosaccharides. There is simple single sugar molecule not chemically bonded to other sugar molecules. And then after monosaccharide, there is disaccharides, and then there is oligosaccharides, and then the big one, polysaccharides. We're going to see three kinds of monosaccharide. One is 3 carbon atoms, triose, and then 5 carbon atoms, pentoses, and the most common one is 6 carbon atoms, hexoses. So important monosaccharides found in foods are, of course, hexoses, things like glucose, fructose, and galactose, and they share the formula C6H12O6. You should remember this from high school. Well, this is the structures of simple sugar that I just captured from books. Glucose here, fructose there, and then the galactose. Okay, well, for your level, you do not need to know the structure. Just remember the glucose, fructose, and galactose. Although hexoses share the same formula, there is slight differences in the location and the functional groups. And because of these differences in the location and the functional groups, you end up with a different functional properties. Fructose existing as a 5-membered ring, it is sweeter. Normally in ordinary class I will bring some fructose, then I will bring some sucrose. I let you to tell the difference and whether it is true what we say here, fructose is sweeter than glucose or sucrose. Solubility wise, we cannot do that in the class. And monosaccharides, the basic units around larger carbohydrates are built. Of course, there are the building units. Disaccharides, they are monosaccharide joined together to form disaccharide via glycosidic bond. The 3 most important food disaccharides are the one that you take almost every day, sucrose. This is basically joining together of glucose and fructose, table sugar that is. And then lactose, well, this is just milk carbohydrates or milk sugar, glucose together with galactose, and maltose, which is basically glucose to glucose. Alright, this is the structure of disaccharides, glucose and fructose. You see the orange color, glycosidic bond between these two, glucose and fructose, to form sucrose. Lactose is just galactose, and glucose also glycosidic bond. Glucose to glucose, also glycosidic bond. Okay, sugar is special. It has functional properties that give rise to many interesting properties in many different food products. So we have 2 important reactive functional groups. One is called carbonyl. This is reducing and involved in Maillard browning, contributing to color and flavor. We are doing very general here. There's a lot of very complex chemistry involved. Alcohol groups readily forms hydrogen bonds with water molecules, therefore contributing to solubility. We know sugar is very soluble because of these alcohol groups. Glucose has 5 OH groups, therefore very soluble. OH also contribute to sweetness. Okay, then we have this reducing sugar, which is the sugar that contain aldehydes and ketone carbonyl groups. All monosaccharides and certain disaccharides are reducing sugar. All. A good example will be glucose is reducing, well, xylose, ribose, galactose. There is a term called dextrose equivalent, or DE, which is a measure of percentage of glycosidic bonds hydrolyzed in disaccharides or polysaccharides. DE will indicate the level of reducing sugar presence. So for pure dextrose, the DE is 100, but starch, because there is no reducing sugar, it is completely a starch, polysaccharide, the E will be 0. So if you perform breakdown, you start to break down starch, it will form slowly, it will form dextrose, and the value of the DE will go up bit by bit. So the higher the DE, the more soluble, and the greater the reducing ability of a sugar. Alright, I'll show you this picture because it represents a very important reaction, chemical reaction in food, and this is due to sugars. Looks delicious there. Okay, it browns. So the browning reactions, one is very famous Maillard reactions, or sometimes we just call it Maillard browning. And then caramelizations. There are two. I mean, you need to know this different because this is so fundamental in food chemistry. So for Maillard browning, you need reducing sugar. For caramelization, any sugar. It is also browning, but this one due to caramel pigment formation. But Maillard browning is due to, well, due to Maillard reactions. Amino acids, therefore you require some kind of proteins. It can happen at low temperatures. It can mostly happen at higher temperatures anyway. If it is low temperatures, it needs long storage time. But both of them produce brown color. The only difference is for Maillard browning, the pigment is called melanoidins. I have no clue. Nobody has any clue what is melanoidin all about. It's very complex chemical interaction and pigment there. Maybe the molecular weight is also high. For caramelization, you produce caramelin, very complex also. But this is due to the application of heat energy to sugars. So for caramelization, you do not need protein or amino acids. But the temperatures is in excess. It can happen at 100 degrees C, but mostly at very high temperatures. So Maillard browning can be desirable. You have aroma, you have flavor, brown color on the surface, etc. Like that. Look very, very delicious. Or it can be undesirable. Sometimes you do not want the browning. Sometimes it becomes off order. Sometimes the polymerization is a disadvantage. It kind of decreases the quality of the food. It can cause toughening. Sometimes if you read this publication in the journal, there is evidence that free radicals are formed during this Maillard reaction. But for caramelization, mostly a desirable flavor, brown color. Okay, so well, do not worry about why it is called Maillard. It is actually French chemists who discovered this, and sometimes also it is called as non-enzymic browning, because there is another browning due to enzyme, but this one is does not involve enzyme. Okay guys, so that's supposed to be enough for part 1 of carbohydrate as food component. I'll do another one later on in the part 2. Thank you.